Hi everyone, and welcome to our video on doing a word problem involving exponential growth. Okay, so we just saw one. I'm going to just scroll real quick where they can give us these notations and then we can convert it to a word problem. Notice on this, we didn't even need, so just a quick note, we didn't even need, I'm going to box it right here, we didn't even need that. They told us where those are going to go. So notice the initial part was right here, and then the percentage part was right there. And then we just need to use an exponential function to plug those in. Okay, so they can word it in different ways. Again, if they give us the thing that's boxed weird, where I'm swirling around right now, we can make this equation, but they could also word it and we can find that equation. So that's what this one looks like. So it looks like they're wording it instead of just giving us a differential equation, and we're gonna rewrite. All right, so it says the consumer price index compares the cost C of goods and service over various years, where 1983 is used as a base. So that's our T equals 0. So 1983 is the base, meaning that's when T should be 0. The same goods and services that cost $100 in 1983 cost $250 in 2019. Now they want us to model C as an exponential function, rounding the growth rate k to 5 decimal places. All right, so we know they told us it's an exponential function. And so the exponential function form, so they wrote it, let me scroll one more time. They wrote it with P in this boxed one. I used the N in this problem, so they can change the letters. And then even to the side, I said, sometimes they do capital A. Okay, so they keep changing the letters on us. Okay, so let's do, all I'm gonna do is say it should be C in this problem. So for C for cost, equals, let's do it like this, C naught e to the kt. Okay, so again, I'm gonna scroll one more time. So it's matching this notation, but I'm using C instead of P. Okay, and I can even change that into C of t equals C naught e to the kt. Okay, so we can change that also. Okay, anyway, so on this problem though, they give us two different things. Okay, so we're gonna number those 1 and 2. And we're going to rewrite that. So it says the same goods and services that cost $100 in 1983. So that looks like an initial amount. Okay, so remember this C naught is an initial amount since that's our base year. So it looks like we should be able to plug that in right away. So in step 1, it looks like we can instantly change it to be 100 e to the kt. Okay, so that was our first piece of information. Now number 2, they're saying it became $250 in 2019. Okay, so that's going to be this amount. So what this amount is, so this is an amount after time t. And we just need to calculate. It looks like, so 1983 to 2019, so we could just subtract those. 2019 minus 1983 is 17 plus 19 years, which is 36 years. So there's a 36-year difference between those two. Let me verify on my calculator real quick. So 2019 minus 1983. Okay, so never being too safe, right? Okay, so 36 years. So after 36 years, something that was $100 is now $250. So that's going to be our step 2. We're going to say, well, this after 36 years, that would be the same as C of 36. But they're saying that is an actual dollar amount. They're saying that should be $250. So what we'll do is we're going to change this left side, this part right here. We're just going to say it's 250 while our time is 36. Okay, so on the left, we're going to have 250 and then equals still the 100 e to the k, but our t is now 36. Like that. Okay, so we subbed some things in. So they're saying t is 36. So I've subbed it into that equation, and I subbed the c of t, or the c of 36, in for 250. And then now we're going to solve for k. Okay, so the first thing we would do to solve for k is divide by this 100. Okay, so now we're solving for K. And as we do that, this would become, okay, so 2.5. Let's just do a decimal. 2.5 equals e to the 36k. Okay, so it looks like that. Now, I'm going to rewrite this part up here in this left side, or right side, I mean. So 2.5 equals e to the 36k, so I'm just rewriting it. And what we need to do, if we ever have an exponential equation that has a variable or letter that we're trying to solve for, we'll need to use an ln. So we're going to do ln on both sides. So I'm going to put ln and ln, and then put the 2.5 equals ln e to the 36k, like that. And the reason that we do that is because this right side, the ln and the e cancel, and we would be left with only 36k. So it's leaving us with the power. The left side just is ln of 2.5. So that's some random number that we're going to plug into a calculator in a second. But let's solve for k entirely, which would be to divide each by 36. Okay, so we've got k. So we've got ln of 2.5 over 36 is k. Now is where we would use a calculator to get a decimal. It said to do it to 5 decimal places. So let's just type that in. So ln 2.5 divided by 36. Okay, and to 5 decimal places, we've got 0.02545. 0.02545. Okay, let's get that copied down. Okay, so our k, so it's a little, I'm going to put it right over here, sorry. K is 0.025, I already forgot it, 0.02545. Okay, so we found it. We found k. I'm going to cloud that. So this first step took a lot more space than I thought, but I think we're okay still. I'm going to cloud that. And then now what we do is we go back to this equation that we first wrote based on the information in the problem, and we just change the k. So we're gonna change that k there into this actual number. And that would be our final answer for this first step. Okay, so we've got c of t is equal to 100 e to the 0.02545 t. Okay, so it crowded number 2 a little bit, but there we go. Okay, but now that we have this equation, so that first step is a doozy, but once we have it, we can answer anything they really want now from the rest of this problem. Okay, so let's see this. So it says, estimate what the goods and service costing $100 in 1983 will cost in 2050. Okay, so again, we just have to figure out how much time passed there. Well, 2050 minus 1983 would be 67 years. Okay, so that's the t value we should use now in this function. So we're going to let t equal 67 in this function. So now that we've got it, we're going to use it multiple times. Okay, so we're going to do c of 67 will equal 100 e to the 0.02545, and then change the t to 67. Okay, and then now again, it's a calculator. Let's just set up the left. C of 67 equals. Okay, so we're going to type all that in. So we've got 100. I'm going to copy this here. There we go. Okay, so we've got 100 E. And let's use our parentheses again. To that number times 67. Okay, so in our year 2050, something that had cost 100 looks like it's now costing $550, and we'll round it to the nearest cent, $550.22. Okay, so after 67 years, based on this model, $100 back then now needs $550. Okay, let's see our next one. Okay, so number 3 says estimate the rate of change. All right, so rate of change is telling us we need to do a derivative. It's still eventually going to be 67 years, okay, because it's the same amount of time, but we are doing a derivative first. Okay, so I have my original function, c of t equals 100 e to the 0.02545 t, and then now we're going to do a derivative, so c prime of t equals, okay, so remember the derivative of an exponential is itself, so it's 100 e to the 0.02545 t, but then times the derivative of the power, which would be just 0.02545. Okay, and then now we can do our c prime of 67. So still using a calculator, so I'm not really caring about simplifying this. I'm just going to plug it in. Okay, so 100 e to the 0.02545 times 67 up there in the power, and then times, eventually after all of it, 0.2545. Okay, so there's our setup, and then back to the scientific calculator, or Desmos. Notice I already have that same thing. Okay, so the 100e, so all of that I've got. I just need to times it by that decimal afterwards. Okay, so same deal. Oops, I typed in a 4 in that one. I just wanted to see them both. Okay, so that was our last one. Okay, but on this one, we just need to multiply it by, after all of that, the same 0.02545, which is $14. Okay, so it rounds nicely to the nearest whole dollar, $14. Okay, so C prime of 67 is $14, and that is per year. So that's how much it's increasing at this point. Okay, so it's increasing, so cost is increasing, because that's a positive number, at a rate of $14 per year in 2050. Let's box that one up, because they often like us to know what the derivative value means in words like that. Okay, so this one's making us do a lot of little work with it, but again, it's always back to the main equation once we get it. Okay, so this last part, number 4, it says how long after 1983 will the cost of goods and services that cost $100 in 1983 be $500? All right, so now we've got same deal. Let's just write down our function that we had from the beginning, or after step 1, the 0.02545 t. There we go. Okay, so we've got this, and then now they're asking how long after. So we're finding t in this problem. Find t when the cost, and the cost is c of t, is $500. Okay, so that means we're going to change this to be $500, and then equals 100 e to the 0.02545 t. Okay, so there's our setup. So that way now I'm just solving for t. Well, the very first step would be to divide by 100, which gives us 5 equals e to the 0.02545 t. Okay, so we saw this on step 1. What we're trying to do is solve for something in the exponent, in the power. So that means we need to introduce an ln. Okay, so I'm just gonna throw in ln right there and there, which means the left-hand side is just ln of 5. The right-hand side, so ln's and e's cancel each other out, leaving us with just the power, so 0.02545 t. And then I want to solve for t, so that means we should divide by this decimal, 0.02545, on both sides. There we go, so that's that division. And so we get t is equal to, so I just want to rewrite t over here, the ln of 5 divided by 0.02545, and then we'll plug that into a calculator. So I'm doing the approximately symbol, but let's write this out, or let's type it in to see what it is. So we've got ln of 5 divided by 0.02545. And we get 63.24. So we'll round that to the, well, let's write 63.24. And that's years. Okay, and so let's rewrite our last statement here to finalize it. So it says, well, it does say how long after 1983. So we could say about 60. So, and they might want us to round that in different ways. So I'm going to say about 63 years after 1983. Or they might say, well, use a actual calendar year. So let's do 1983 plus 63. So sometime in the year 2046. Okay, so around 2046. And I put around, so sometime based on this model, sometime right in the middle of 2046 or early on, so 63 years after. But really 63.24, so maybe like February or March. Okay, so something like that. But I don't think they would ask that. They would probably just want a calendar year or the first way that I wrote it. Okay, so there we go. So these problems, yeah, they could take a while. Notice we only want the derivative, though, with the rate of change. So because they're giving us information to really use exponential functions. Okay, so it's a little bit of a review of some pre-calc stuff, but stay patient with it. Okay, so that's it. If you do have questions, please let me know. Otherwise, thanks for watching.